everyone, in today's video we're going to talk about the three special limits. Okay, so we have here limits of sine x over x as x approaches to 0. If we would do a direct substitution, the result would be 0, which is it could be a problem. We will investigate the values of sine x over x as x approaches to 0 from the left and from the right. We're going to use the values of negative 0.1, negative 0.01, negative 0.001. And we're going to use the same values as x approaches 0 from the right. This time, we're gonna use a calculator and make sure that it is on rad. We will just substitute to know the answer. This is what you need to do. Sine multiplied by negative 0.1 and divide it into negative 0.1. And then you'll get the answer. Same goes to others. So the answer would be 0.998. We would do the same process to other values to come up with these answers. As you can see, if we add it all together, the answer would be 1, which is correct. This is our example 1. Now let's move on into example number 2. Now here in example number 2, we will going to investigate the limits of 1 minus cosine x over x as x approaches to 0. We will just gonna use the same process and same values by using a table as x approaches 0 from the left and right. As you can see, we would use the same values that we use in example number 1. Now let's substitute the following to get the result by using a calculator. Again, make sure it is in rad form. Add all the result that we get from the following values and we would come up to a result which is 0. Okay, now let's move on into the last limit that we would evaluate. We have here limit of a raised to x minus 1 over x as x approaches to 0. Again, we're gonna use the same process and same values from the other special limits that we evaluate before. Substitute it. So limit of e raised to x minus 1 over x as x approaches to 0 is equals to 1. As we add all the result that we've got from the values. Same goes as x approaches to 0 from the right. That just means that it is correct because it has the same result as x approaches 0 from the left. Let's say for example, limit of sine 2x over 2x as x approaches to 0, they look the same as the first special limit that we evaluate, so that means it is also equals to 1, as simple as that. Example B, limit of sine x minus 1 over x minus 1 as x approaches to 1 is also equals to 1, since it is also looks the same as the first special limit that we evaluate. Now continue to watch the video as we would provide lots of examples for you to understand the three special limits that we tackle on this video. You just need to remember that if it has the same orientation from the three special limits, it is expected that the answer will be the same.